Balaji. He worked in Singapore and Australia as a technical consultant for about 2 years. In India, he worked as an assistant professor in the Department of Aeronautical Engineering for Hindustan University about 4 years and as an instructional designer for 3 years in India. He has completed dual masters in India and Singapore. In Singapore, he has done his Master of Science in Precision Engineering with specialization Additive Manufacturing and also Master of Engineering in Aeronautical Engineering. He has published 8 Indian patents in mechanical, aerospace and manufacturing.
Welcome to UGC lecture series on additive manufacturing. Today our discussion is about 3D printing process. So first, how it is going to be processed and what are all the variants in it and how the process parameters which is going to accomplish the product development. So first, how you know, it's like common principle. Either we need to have some material to bind the powder. It may be of either form, like we may use directly a binders, or we may go for binders on the material, or we can directly go for using any other method which can binds the material. That is the basic logic here. So it may have a number of variants while binding a powder, right? So based on that, the 3D printing category has been categorized. So we have 3 or 4 variants based on that. Okay, first initially as we start with normal CAD file, along with we need to have STL file conversion, and finally we need to have the input as a layer, right? That is for common all AM process. Here as we have initially we need to have a powder bed, right, which is going to act as a supportive as well as product development area, right? This is the area where it is going to develop a product as well as this is going to act as a supportive as a product development tool. So this is how the system going to work. So initially we need to spread the powder, right? We are spreading the powder and then we are slowly including the binder. This is based on the product development or the layer thickness, right? The binder is going to be fused and it is going to make a 3-dimensional object, and finally we have the end finished product by removing the powders. So this is like a common process. Followed by we have what are all the basic how it is, like we have go for n number of variants in it, like we can go for plaster kind of material or sand or ceramic, sugar, starch, so many materials we can go. Even food printing, they are using this 3D printing process directly. They are printing the chocolates directly or cakes or whatever maybe, and some of the materials they are making pizza stuffs, like on top of pizza they are developing. So all this they are using the common 3D printing process. The process is comparatively little faster because it really doesn't depends on the atmospheric conditions. So we can make it anywhere. It is open source ended, so we can use it anywhere else. And as well as cost is comparably low. Okay, that is some of the advantages based on that. So these are all the components. You can see how complex parts they are making. Some of the examples based on that. So we don't have any constraints for making the components in this one. That is one of the advantage in 3D printing. So this came up with so many variants. So we have go for any industry irrelevant. We can go for any other industry. So we can, based on this process, we can go for all the industries. We can say we can cover all the industries based on this process. So it really depends on the material. It really depends on depends on the material or atmosphere or whatever maybe. So how this going to be achieved? So some of the first variant is we can go for a direct. First variant is solid based variant, that is particularly the powder one, right? Solid, you know very well, we prefer to go for powder kind of stuff in manufacturing. So you can see the powder here. You can see the powder here that is being laid up. So on top of it we can see supportive powders. This also a powder, right? This is not like any other supporting material. As I said, we really don't want to concentrate much on supportive materials too, right? So this is how they are making, and finally like a normal process after it should be spreaded, and if you really need, we need to go for a heat supplement and binding together. The process is common, but the variant is here we are using powder, right? Followed by some they are mentioning it as it's a semi-solid, or some they are mentioning it as liquid, but most of the cases the material seems like semi-solid state, but some areas they are mentioning it as a liquid, in some areas they are mentioning it as a semi-solid condition, but prefer to use, I think it's semi-solid is a better word, because most of the time we can see the material is almost in a semi-solid kind of material. So you can see the binder based one, semi-solid. First variant is binder and second is directly material deposition, right? So first is binder based. You can see the binder is being deposited on the required area. Slowly this is one going to spread, the dispensable powder is going to be spreaded, and that is going to act as a bindable powder here, right? This is going to be the delivery unit for the powder, and this is going to be the binder dispensing unit. Okay, so again the process is same. Once it is deposited, the powder is going to be leveled and the binder is going to be added. You're going to get a 3D dense product. So process is again the similar one. Here you can see the material is directly dispensing, right? The molten plastic, molten in the sense you already know what is the state of it, so you can easily dispense and it is easily get solidified, right? The state phase change can be attained very easily. That is the advantage here. You can see how the molten plastic is directly delivering and it is dispensing, and we can get the product as we require. And we have the flexibilities as you shown with the help of this arrow. You can tilt the angle as we need, right? So there is no worry about the shapes of it. As we seen, we can go for n number of irregular shapes. It is not particularly defined about how the shape we require. We can go for irregular shapes. That is a major advantage in open 3D printing processing. And this is one of the key areas where we can really concentrating many, all over the world there are many are concentrating on this area, particularly bioprinting, which is they are focusing on building the entire organ. Say for example, if I need an organ, heart or liver or kidney, I can just directly print and I can fit it into my body. That is one of the major advantage for that. How they are processing, till now we really don't have the real component built. That is, we don't have any functional organ print yet. Still they are in processing phase. But how they are achieving as a normal process for 3D printing, that's why we are have a separate thermal base for that, because this material is easily get contaminated compared to other material. So and also we are going to use as a living tissue. It is going to be inside some of our bodies, and that is going to work as a normal functional part. So you can understand how the system should be cleaned, and environmental how we should keep it as safe, right? So as we have, this is the yellow color resembles your living cell, right? And this injector is going to act as a binder. That's it. It is not really going to contribute much. How they are doing that, they need particularly two major components. That is based on how it is going to be bind. Particularly they are naming it as bio ink, right? You can see the bio ink. This they are naming it as spheroids. Normally we can have spherical shape which is going to stick with. So they are naming it as spheroids. That's what. It really doesn't have any other related meaning. So you can see the bio ink is dispensed like a layer, right? Or in this case you can see how it is dispensing. It's act like a entire sheet, not as we required on a particular place. Can you identify the difference? See here you can see this is going to be act like a entire base for this gel to stick with. Why and why they are specifically using this kind of methodology? This bio ink has a capability to dilute in a daytime. I mean, after a particular time period, this bio ink degrade in a normal temperature itself. But during initial state, we need to have it as a binding component. So that is a major advantage. So you can think it of how we need to generate this process. They are achieving it very simply. They are taking cell from our own body. As we need, they are modifying it, right? Say for example, they are taking tissue cells or stem cells. They have a number of names related to medical terminologies. But what the concept is, they are taking cell from our own body and they can generate whatever related component based on our living cell for our own body. That is how the system is more suitable for a particular patient, right? Even this is much better than organ donating, right? Because that is been in another body and it is going to act in our body. But this concept, they are generate the entire organ from our own body cells. So there won't be any deviations from DNA level changes, or so many changes are there. As we have some problems are there, this material also needs some time to cope up with our own body environment. That issue is there. But that's why they prefer to go for all biodegradable material, or particularly the material which is easily adapt to our own body conditions. Now they have modified a number of things. Internal, they are building organ with internally they are building arteries and veins as we have in our body. So likewise, we can go for a number of alterations. For that initial build-up, this binder is going to be very much helpful, right? So as you see, each and every stage they are building, and finally your living tissue will be in this shape. So this is only your living tissue, the final living tissue. But as we have some issues in AM, here also we have some issues, because the entire component has more internal structural growth. Particularly, you know very well, most of our organ is not only like a normal component what we are building. We have internal modification structure is there. So you know very well, some of the arteries are going, veins, and we need to have access for all those components. And also generating component, we really don't know how it is going to, for a grown person, say for example at the age of 12 our organ development will be in different state. So until attaining the matured level, maybe 21 or 22, until that there will be a sequential stage development in our organs. Those difficulties still they are facing. You heard about some of the famous problems related to eyes, like glaucoma. Glaucoma, they are naming it as, still we don't have any treatment, but they have some of the materials, some operations they are doing in abroad at the moment to avoid glaucoma. Glaucoma is basically depends upon the eye pressure which is present inside the eyes. So they are using some other technology to maintain the eye pressure like a common human beings, so that we really don't want to lose our vision. But till now, what is the scenario is, if somebody is affected with glaucoma, they need to lose their vision. That is the only way. So likewise, in bioprinting, they are been developing so many things based on that. So if you specifically work on it, there are n number of scopes in this area. So again, we are going to see about some of the process related to this 3D printing, right? What are some of the basic process here? It's like, as I said, it's an open process, open source process. We need to know how much it is going to be filled, that is infill. What is the component is going to be occupied within the area of concentration, right? That is going to be defined with the help of infill, followed by number of shells that I'll explain to you, layer thickness, followed by temperature, printing speed, and movement speed. As I said, infill is the solid material which is going to contain within a material, right? Say for example, I'm building a process, some areas where I really don't want, I can leave it as a empty space, right? But in some special cases, I need to have a very solid, rigid structure. In that case, I need to use this material. So normally, this infill, if the material really doesn't want additional specification, we can go for filling it 20 to 30%. That is fine enough. But in some special cases, as I said, if we really need additional supporting materials, that is going to be a entire wholesome figure for it. So in that case, we need to go for filling it more than that. But in this scenario, the normal ratio is 20 to 30% is sufficient to handle with, right? And followed by the number of shells. Number of shells in that sense, what they are specifying it as, like if we have outer section, as we've seen, we have powder as a supporting material, right? What is the tendency of the powder? If it is really impacted with some additional heat treatment or heat supply, it may move, or it may allow the material to move to the nearby area so that the material can lose its shape, right? So that process can be avoided if you really have very denser outside, right? Outside surface is denser, it is easy, right? It won't allow the material to pass over from that particular area, right? So that's why we prefer to go for printing the outer shell alone with some higher density. Generally, we have go for almost twice of normal what we are printing inside. Maybe the inside part may have a density which is twice as which have additional supportive to the outer boundary. Outer density may be twice as that of inner boundary, inner material which is being filled, right? So what is, as I said, the advantage is it won't allow the material to expand or spread to the nearby materials or nearby powder, right? So that's a major advantage. That's why I prefer to go for having printing a denser outline, right? Outside wall, followed by a layer thickness. Layer thickness is a common parameter, as we know. If you are going for very thinner, the product development have very smoother finish, or we are going for very thicker component, again the product, what will happen, the shape or the surface finish won't be in a better condition. So what we need to know, we need to go for a optimized process, and we are using a thinner and thinner layer thickness. We need to go for more processing time. It will take more and more time to attain a real component, right? That is like a common process. Again, the temperature, particularly while printing, you can see we don't have any closed atmosphere. We can using like an open end area. So the temperature has to be optimally maintained within the delivery unit itself, right? It may be a binder, or it may be a solid or semi-solid, whatever may be the case. The binder itself should have sufficient temperature controlling unit, or otherwise it will lead to material distortion at any time, right? So this really plays a vital role, because here that is a only area to control the temperature. In some of the AM process we have seen, we have additional temperature control unit. Here the mostly it is depends on the material delivery unit. The worst case, we may go for additional supporting, particularly the bed temperature we can maintain. That is one of the additional support. Or as we see some of the binders, we are using both binder and as well as the powder. In that case, we can have a option of controlling temperature in both the delivering unit. Like one is delivering the powder, another one is going to deliver the binder. We can have option of controlling the temperature. So here they have made up of a number of variants very easily. Some of the industries, they came up with flexible head. You can use, it may work around everywhere. So they, in that case, they have additional options of controlling the temperature, right? Or otherwise, the only controlling area here is the delivering unit. The printing speed that we know, what has been extruding or what is the material which comes out, that has to be considered as a printing speed, particularly only during dispensing the material. Material dispensing part, we are considering it as printing speed, and the normal movement of the lever. Say for example, I have hollow structure in particular area, I don't want to print any material. In that case, we are considering the movement as normal movement. Generally, during delivery, the speed is very idle or in a controllable level, particularly where we don't want to dispense a material, but simply the lever is, the delivery unit is moving. In that case, we prefer to go for higher speed. Particularly, we can go for twice or more than that of what we really want to print. Particularly the delivering speed. Particularly while we are delivering the material, we should have very particular speed, or we should be very concerned with the delivering time, that we know what are all the parameters associated with and how it is going to affect it. So, but while simply moving the delivering unit, that time we are not really concentrating on speed, because it is simply going to move, it is not going to dispense any material, but we should be, the care should be taken that it should reach the next point in a prompt manner, right? If it is exceeds or lags, that really creates a difference, right? These are all the basic parameters very specific with 3D printing process. Like other processes, we really don't have any other additional mechanisms like any delivering unit like a laser or EBM, any other additional supports we really don't have. So here all the control has been taken by the delivery unit itself. So the parameters mostly associated with delivery unit, right? Okay, in this session we have discussed about 3D printing process and what are all the variants in it and how the process parameters associated with that. So if you have any question, you can ask.
Sir, in the process parameter you specified about the infill. Why is infill is more important than other process when compared here?
Like particularly as we have additional, as I said, we can concentrate more on supportive structures. We may go for additional supportive structures very easily in other parameters. You can, if you're going for open end process, there we really like a powder we are been supporting to that. In that case, we really don't want to concentrate much on supporting structure. So in that, if you have a control over the infill, that is like an inbuilt structure support, that is better compared to other processes. That is a basic difference. Like if you really need like all other parameters associated with us is comparatively is much related to infill as well. We really doesn't mean that in other AM process infill is really not in concentration, but the thing is, compared to that, here we need to focus in addition to that, because we really don't have any closed atmosphere, we really don't have any supporting structure. That is why we prefer to go with particularly concentrating more on infill area.
Does that means in infill in FDM or SLS process we will be having some specific structures like Criscas or something like that? Does this infill means here density at that particular point will be lowered like that? The powder dispersion will be very less like that?
See, very simple. If I have any support structure, right, it is going to hold my whole weight. In that case, if internally the material, if I am using lesser, I can reduce the support weight. Can you follow it up? In such a case, how can I neglect that issue is, if we have entire support, right here I have complete support of the powder. So in that case, I really don't want to focus much on supporting structure. I can build even the thicker or thinner material as we need, right? So that's why I said infill, we can even like this parameter, we can easily play around with compared to other AM process. That's the basic idea. Why we really focus much on infill, this is the basic idea. Because as I said, the structure really need additional support. In that case, we really don't have any other option at all, whatever may the AM process. But here, we can manipulate as we need. Please note the questions. Explain the 3D printing process with diagram. List the process variants of 3D printing and explain about bioprinting in detail. List the process variants of 3D printing and explain about bioprinting in detail. Explain the process parameters associated with 3D printing.